Hi friends, we are back with the third video in our Robotics Software PicoDegree. In today's video, we will learn how to integrate Webots with ROS. So today, we will see how the actuators in Webots can be controlled by services in ROS. After which, we will see real-time output of sensors in our ROS system. And finally, to wrap this up, we have a great application where you will be able to control your robot with Teleop, that is, with your keyboard. So, by the end of this video, you will be fully equipped with how to add sensors in Webots, how to enable those sensors, and finally, how to get those values in ROS. And also, if you are a fan of gaming, you can also be fancy and use your joystick to control your robot inside the simulator. Once your software is ready, you can use that to deploy it on a real robot. So, without wasting much of our time, let's get started. So first of all, let's prepare our repo. I have a workspace named Webots_workspace in my desktop. I have a source folder. This is where we have a repository named Robotics PicoDegree. So for this video, you should go to that repo and do git checkout to Teleop branch. This branch is specifically made for this particular video. For my case, it's already in Teleop branch. I need to go back and do catkin make. So this will build our program. Now we will see the output which we will get at the end of this video. Let's source the workspace and ROS launch. Bring up master.launch. So when we do this, we will see two things. One being the Webots, and I also have ROS. So first of all, if you closely look, we see a blue color line around which shows that we have a LiDAR, and this is a field of view of our LiDAR. Also, if you notice different in this video is we see a camera view which is being pursued by the camera. So in this video, pretty much we will enable all the sensors which we have in our robot, and also, as promised, we will have our robot operated by the keyboard. When I hit my front button, robot starts moving. If I hit right, it starts rotating, and you see the camera view is also changing depending on robot's position, and accordingly our LiDAR is also changing. Let's stop the robot. We also have our mechanism where our camera moves up and down. So we are using W for our mechanism, our camera to go up. Our S is for going down. If I hit on A, it rotates, and D, it rotates in other direction. If you hit any other button, the robot will stop. Now let's have a look at our ROS. So in this case, let's set up our fixed frame as base link. So you see our robot which has all the different links. When we move our robot up and down, our camera link moves as well. This is very important because if we are implementing a computer vision pipeline, it is essential for us to know the position of sensor with respect to robot. You also see it rotating, because if I am detecting an obstacle, it is better to know the position of obstacle with respect to base link so that robot can avoid it. So these were the two features, and also if I open a new tab in my terminal, if I do ROS topic list, So you see here we have different sensors which are published. So one thing to note here is Webots has a nomenclature where they write the name of their robot first, then they write the type of sensor, and then at the end they have depending on what that sensor gives. So for this case we have a camera which gives image, so this is a camera topic. Similarly, you can see different things like here there is a laser scan. So if I quickly echo ROS topic, echo one of the topics, let's choose camera and DS left. So let's see the value of left distance sensor. So if you see here, it is giving me the value of 1000 because we are not seeing anything in front of the distance sensor. So by this way, you can go through each of the topics and see how the output is. In Webots, there are many services. So if I do ROS service list, so you see Webots gives extensive list of services for setting different features of our sensors. So you see there are some services which includes camera, some have IMU, some have LiDAR, etc. So today we will see a node where we use these services in order to enable our sensors, and also we will use these services to move the robot. So you see here we will have some services which will be wheels. So we have 4 wheels. So wheel 1, wheel 2, wheel 3 and wheel 4. We have different services: get the velocity, set torque, set position, etc. So we will use these topics and services. So if you feel that you have different kind of sensor which is not available with us, Webots has done a great job in terms of documentation, where you can search whichever sensor you have. For example, we will go through GPS here. They will teach you how to enable these sensors by this in your proto. And you have different tabs here. Like if you are using C, you will use these functions. For us, we are using ROS. So in order to tweak our GPS, we have a topic which is robot name / device name / value. We have one more topic which will be robot name / device name / speed. And we have 2 services, one to enable the sensor and other to get the sample period. Now let's dive into the master.launch, where this is a starting point of our ROS code, where in this, first of all, we launch Webots environment with our world name as home.wbt. Then we have couple of nodes here, like we have a teleop node. And if you are new to ROS, this is how we define a node. So we have 2 nodes here, one being node used for teleopt, and second node is which is publishing our dynamic links. Also we have URDF, which we saw in our last video, and RViz. So first of all, let's have a look at 2 major nodes which are been implemented for this video. So you see here we have 2 nodes with their header files and their CPP files. So first let's go through the architecture of our node. So in this case we have our node subscribing to model name topic. So if you want to see what this / model name is, so if I do ROS topic echo / model name, you see here we get a big name which is assigned to our robot. So this name consists of proto. So this cam_robot is our proto, and this number changes every time you spawn new master. So in your case this number will be different. and at the end you will have your username. So this is how different robots of same kind can be namespaced in Webots. That is why Webots is a great tool for multi-agent robots. And if you have a close look, if I do ROS service list, so you see most of the services are with the robot name. So if you see any service, it is divided into three parts. First is robot name, second is the sensor name or an actuator name, so in this case it is wheel, and last thing is the application. So for most of the sensors in Webots, you will have a service to enable the sensor. So let's take an example of IMU. So we have a service which is robot name /IMU/enable. So pretty much for all the sensors we'll be using this service, and this service takes an int which is the timestamp. So if you see here in our node, we will be subscribing to model name, and we will use this model name inside our robot name /sensor and enable. So we will enable all the sensors in this way, and secondly we will set positions to be infinity and set velocity to be 0 for all the wheels and actuators. So these are the sensors which we will loop through and enable one at a time, and these are our actuator, which is wheel 1, wheel 2, wheel 3, linear actuator and rotary actuator. This file also does teleop. So if I look at the file structure, it is basic header file, and we should have a look at two main functions, which is initialize sensor and teleop. So after this header file, let's go through the CPP file. We have a constructor where I am calling model name as we saw in our architecture, and let's directly jump to our initialize function. So in this function we made a smart way where we have list of sensors, after which we make clients to the services. So you use, this is the syntax where you'd use service client, and your services are used as robot name /sensor/enable, and pretty much you make a vector of clients, after which you wait for the service to spawn, and finally you call the service with timestamp. So in our case the timestamp is 32, and that is how we will get the output of sensors every 32 milliseconds. Similarly, we also enable our keyboard because we will be using keyboard for teleop. And finally, we also have a for loop which loops through all our actuators. So similar to the sensors, we have a vector of actuators, and there are two modes in Webots. You can have position control in your sensor, or you can have velocity control. So in our case, we are using velocity control for the wheels. That is why we are setting the position as infinity, and we are setting velocity as 0. So this is how we are enabling the sensors, and we are setting 0 velocities to the actuators. After looking at this function, now I feel teleop function will be really easy. So first of all, if I do ROS topic echo on 15 HBK keyboard key. So if I subscribe to this topic, if I click on W, I should see on my terminal I see number 87. So in our keyboard node, all the keys are mapped to a particular number. So in our case, top arrow key is 315, back arrow key is 317, and similarly. So if you want to use different controls for your robot, you can just echo this topic and click your respective numbers. You will get the data here. and you need to save that data somewhere. So for our case, we are using up, down, left, right keys. Similarly, we are using WASD to control the camera. So this is an easy switch case where if I see 87 on the key, for me 87 is W is stop. So I set the linear actuator to 0.1 and rotary actuator to 0. That means actuator will start going upwards. Similarly, -1 actuator will start going downwards. Here I'm giving 65, which is A is on the left side, so I am giving a rotary velocity of 0.4 and linear velocity of 0. Similarly, rotary velocity of -0.4 and linear velocity of 0. This is how in these 4 cases we control our camera, and this should not be a surprise to you guys. If I press up arrow key, which is 315, so in 315 I set all the wheel speeds to 2 and I set actuator speeds to 0. Similarly, if you click back arrow key, your velocity will become -2. If you turn right, your right wheels will go reverse and your left wheels will go forward, and similarly for left side. And finally, if you click any other button, our default is implemented, which gives all the zeros. Now we will see second node where we are publishing transform between two links, which is moving with respect to a sensor. We are seeing here the architecture of our second node where we subscribe to two sensor topics and we publish two dynamic link using TF publisher. We have two yellow boxes which publish dynamic link and one green box which is a static link which is defined in our URDF. Because of this node, we have a relation between base link and camera link at any given instance of time. To go through the relation between base link to camera link, we have to go through series of links where we have relationship between base link to linear link to rotary link, and rotary link to camera link. So this is pretty much what we are going to do in this node. So if you see here, there are callbacks of linear sensor and rotary sensor, and we have functions to publish the transformation between linear links and camera link, and this is a helper function to convert to Euler angles from quaternion. So if I see its implementation in the main, I will make a member variable of this class and I will pass the node handle so that it can use this node handle to publish and subscribe different topics. So once this class is made, we come to our constructor of the class where we subscribe to model name. Once I get the name, we call two different functions which initialize the subscriber. So you see here we are subscribing to robot name / linear sensor / value, and again robot name / rotary sensor / value. Once I start getting these values, when I get a linear value, we publish linear link. When we get a rotary value, we publish a rotary link. So we will just see one function, linear link. So if I see this function, we need to make a variable for TF broadcast. Then we need to make a variable of type transform. Then we set x, y, theta here. So this is my x, y, and theta. And I have quaternion. So I'm setting quaternion as 0, 0, 0. And finally, when this is made, we publish this particular transform here from base link to linear link. This is a bit difficult because you will not traditionally see publishing TFs, but if you have a look at it twice or thrice and if you read about TF, this should seem pretty obvious. Similarly, we again take the angular value, change the quaternion and publish it. So this was all about this node. So after having a look at these nodes, we will look into cmakelist. Cmakelist is a file which is used by catkin make to compile. So this file has different things like versions of cmake. We need to specify all the packages which we are using in our node here. So in our case, we are using sensor messages, geometric messages, and also we uncheck the include directories because we have header files in include folder. So by this command, we include the header files. And finally, when we want to make a node, this is a syntax where we need to add an executable. This is the name of our node and its executable will be made by name enable. Then we link all the libraries which we define in catkin libraries, which we define up. And finally we merge everything. So we add all the dependencies and name it as enable. So this is the name by which your node will be specified, and this is exactly the name which you define in your launch file. So if you see, we define here dynamic link camera and enable. And finally, last but not the least, we will look at Package.xml. This seems like a file which is never used, but when you are deploying a project, you need to make sure that the user has installed all the dependencies. So when you specify the dependencies here, if you remember it, in the first video, we did ROS deb. That command pulls all the dependencies from your package.xml and builds for you. If you have different kind of sensors or you have different drive of your robot, do comment, and if you like the video, do share and subscribe to Soft Illusion. And also stay tuned because this series has just started. Thank you.